Hello, differential equation students, and welcome back to section 3.3. This is video number 2. Okay, here I'm just going to be doing the single problem that you actually see in front of you right now. So now would be a great time to pause the video and make sure you got this problem copied down. Okay, so as we look at this problem, some things to note, right, or some things to wonder, are each one of the tanks, A, B, and C, are those all contained systems where they're non-changing, right? So here, like, I see this 4 gallons going into A, so it gets 4. It also gets this 2, so it gets plus 2, but then it loses this 6 for 0, right? So this is like a contained, right? So this is like a neutral tank, like it's not gaining, it's always staying at this 100 gallons. B, okay, B is losing 2, it's getting 6, it's losing this 1, or I'm sorry, it's gaining this 1, and it's losing 5. Okay, well these again cancel each other out, that's another neutral tank. Here I have a minus 1, I get 5 from down below here, and I'm losing 4, okay, and that's another neutral tank. So these all are staying at their exact same volume, okay, throughout. So that kind of helps us out to start. And now what would be really nice is if I can just go through and I can do this type of math right here. I have each one of these almost like set up already. Like this A here, you can see this positive 4. Okay, well it's getting, so for A, it's getting 4. It's getting 4 what? Pure water. So that's 4 gallons per minute, right, of water. Oh, well, water would be 0 pounds of salt per gallon. Okay, it's also getting 2 gallons per minute from, oh, well, where's it getting that 2 gallons from? Well, it's getting it from B. Okay, well, B's amount would be B, I could put up T here, but from now on, that's B of T over 100 because it's 100 gallons here. But from now on, instead of putting this T, I think I'm just going to exclude it, and it'll have to be understood by you that this B is according to time. Okay, so I've taken care of the 4, I've taken care of the 2. Next is the 6. I have to subtract 6 gallons per minute, right? And where am I losing that? Well, that's coming out of A, so that's A out of 100. Okay, and right there, right, my initial one there, that is for A. Okay, in fact, maybe I'll take some space here and maybe we'll simplify it, right? This is 0. This would be what? 2 over 100. 2 over 100, which would be 1 out of 50. And I think in this case, I'm going to try to write this in order. It's 1 out of 50B. Sorry, quit breaking the action there. Where was I at? Oh yeah, that's right. I was going to simplify this. So I want to put it in order this time. So B will be second because of the alphabet. This negative 6 over 100 would be negative 3/50, and that would be times A. This is A positive. Here I'm modeling dA, the change of the amount of salt in A according to time. Right? Now, I did that one in red. I think the next one maybe I'll do it in green. So this one here, B. Okay, well, my handwriting is a little bit messy there. It looks like B, though. You can always go back up here, right? It looks like it's losing 2. Right? I'm losing 2 here. So when I go to model B, I'm losing 2. Oh, okay. So is it gaining any then? Well, I'm losing 2 here. I am losing 5 down here. But I am gaining 6 from A. Okay, 6 from A. So that's 6 gallons a minute from A. Well, that's A then over whatever A is worth, and it's 100 gallons in there. I'm also gaining, right? I'm also gaining up here 1 gallon from C. Oh, so plus 1 gallon a minute from C, well, C over 100 gallons because it's 100 gallons inside of C as well. Minus, right, that minus sign is really off. So I have minus, what's it losing now? Well, B would be losing this 2 gallons. So B is losing 2 gallons. So that's 2 gallons a minute from B. That is a terrible B. That's even worse. From B. Okay. And it's also losing this 5 gallons. Now it's still being pumped out of B. So I'm still times B over 100. Which, if we do a little bit of math then, right, this is dB dt. Simplifying, right, I had 6 over 100. That would be 3 out of 50. That's an A. Here I have a C. Here I have no other C's. So I said I was going to try to do this in order this time. So this is plus 1 over 100 C. Now my B's, these actually are both negative. That's 2 over 100 and 5 over 100. Both negative, so that's negative 7 over 100. And I'm going to place that here so I have a, a nice order to it. Okay. And finally, I feel like I'm ready to move on to C, right, which is here. It's losing 1, so it loses 1. It also loses 4. It only gains the 1 5-gallon stream there from B. So C gains 5 gallons per minute from, well, where's it getting it from? Well, it's getting it from B. Minus, it's losing 4 gallons a minute. That's out of its stock. And it's also losing, so I've done that 4 gallons down here. It's also losing this 1 gallon. Again, it does not matter necessarily where this is going. Don't let the different letters confuse you. It's still coming from C, and it's still at 100. Even though both these are coming out at the same time, we're also getting this 5 in at the same time. Which, if I simplify this a little bit, that's dC over dt. The A portion, well, I have no A's up here at all, right? There is no A's there, so I can kind of skip over that. The B is 5 over 100, which is 1/20th. B. And it's also 5 over, well, where is it? Let's see here. Well, 4 and 1 would make 5. Yeah, so that's a negative 1/20th C. And, of course, each one of these technically gets this of T, right, throughout the whole thing. And we have our system, okay? The question is, could we solve that system? Well, we have, let's see here, 1, 2, 3 equations, differential equations, and we have 1, 2, 3 sorry for bouncing around there, 3 there independent variables, or I'm sorry, dependent variables. This t value is actually independent, and it's allowed to be in there as the 4th constraint, just like we were solving the other ones. That completes the videos that I absolutely have to do for 3.3. I might throw one more in doing a different type of modeling situation if time permits.